This section is a little bit of review on finding the greatest common factor out of a couple different terms in an expression. So let's start out with 9v squared plus 12v to the fifth tx. What we're looking for is to break this down into all of its factors. So a lot of times an easy way to do that is to use a factor tree. Our constant 9 we can break down into 3 times 3, because those are the two prime numbers that compose 9. And v squared breaks down to v times v. On the other side, we have a 12, and we know that 12 is 3 times 4, but we also know that 4 is not prime. We can go farther with that to break it down to 2 times 2. And because we went farther than that, I'm just going to cross up as 4 so we don't think that it's one of the factors later on. Then we have our v to the fifth, which is just v times v times v times v times one last v. And then we have a t, and we have an x. So these are all of the factors of each of these separately. To find the greatest common factor, we see what factors they both have in common. So I can see here that they both have a 3. Looks like none of the other constants are in common. Look at the variables, they both have a v, they both have a second v. But other than that, all the other ones are different between them. So to find the greatest common factor, you simply multiply all of those common ones together. So 3 times v, and that's going to be equal to 3v squared. So the greatest common factor here is 3v squared. Do another example. We have 19q to the fourth y minus 57qy. First thing we want to look is our constant. In this case, it looks like our 19 is actually prime, so we're just going to go ahead and write 19 as one of the factors. There's nothing we can do about that. Our q, we know that can break down to q times itself 4 times, so q times q times q times q. And finally, our y is going to be up front. The second term here, I'm going to actually pull that negative into the term such that it is one of the factors. So we'll make -1 a factor. So -1 is one of the factors. And then we have a positive 57 left over. Might not be obvious at first, but it happens to be 19 times 3. So I'm going to go ahead and write that in. 19 times 3. Sometimes, if it's not an even number, if it's an even number, you can always divide by 2. If you add the digits together, in this case 5 plus 7 equals 12, if the sum of the digits is divisible by 3, then the number itself is divisible by 3. So that's always a good way to check, is 3 a factor? And again, if it's divisible by 5, it'll end in a 0 or a 5. And you start to pick up on some of these common patterns so that you can identify small factors. So in this case, it was divisible by 3. If you divide it by 3, you get 19, and 19 is prime. So 19 and 3 are both factors here. And then we have a q to the first power, so I'll just write that as a factor, and a y to the first power, so I'll write that. So let's look for what our common factors are now. First of all, both of them have a 19 in common, so we'll write that one down. I see that both have a y in common. Highlight that. And it looks like they both have a q in common. If you are looking to take a shortcut, we did it the long way for the last two examples. One of the things you can do is just look at the original problem. Once you get your constants, you still usually have to do that the old-fashioned way. But once you get your constants, you can look and say, okay, I see a q in both equations. What's the highest power? In this case, it's q to the fourth. Here it's q to the first, so q to the first is the highest power. And thus, you're only going to have one q in common. And that's what we got when we did it the long way also. Same thing with the y here. Have a y in both terms. Highest power 1, highest power 1. So y to the 1 is going to be in my greatest common factor. So let's go ahead and compile the results we got here. We said we found a 19 in both, so I'll put the 19, the constant, up front, times a q that we found in both, and a y that we found in both. So that can simply be written as 19qy. And that would be our greatest common factor. Let's do one last example, and let's take the shortcut on this one. We still have to do it the long way to find our factors of our constant. So 57, we just did that one, so we know that that breaks down to 3 and 19. I'm going to pull the negative into this term. So our negative 6 is going to factor into negative 1 times 2 times 3. Those are all the prime numbers that multiply to negative 6. And our 15 is just going to be 5 times 3. So let's go ahead and identify, just from the constants that we worked with, what is the common factor or factors. They all have a 3, and it looks like that's all they have in common. So we'll go ahead and put our 3 down here. Now let's look for our variable. What's the commonality in our variables? I see a q here, a q here, and no q in the last term. So we're not going to have a q in our greatest common factor. I have an r, oops, no r. So since it wasn't in all 3 of them, no r in our greatest common factor. And finally at the end I have a t to the third, a t to the first, a t to the first. So all 3 of them have a t. The highest power was to the first power, which means that I'm going to have a t to the first power right here, which can simply be written as 3t. So our greatest common factor, even though these numbers are all pretty big, is actually the small 3t.